welcome back to another Go Math 4th grade chapter lesson. This is lesson 7.1, and it is add and subtract parts of a whole. Our essential question today is, when can you add and subtract parts of a whole? So this is the question that we will be trying to answer with our new knowledge today. If you are following along in the Go Math book, this is on page 271 is where we're going to start. I'll let you know when we flip the page and such as well. Again, this is if you're following along in the Go Math chapter book 7.1 or lesson 7.1, page 271. 79. Whoa, page 279. Sorry to everyone I just confused out there. Page 279. It's there in the bottom right corner of the screen. Okay. So, now that we know what our central question is, what we're doing, let's go ahead and erase all of this and get started with our lesson. On this page, we have a picture of some pie and this wonderful woman named Mrs. Clark. And she has the following pie pieces left over from a bake sale. So we have these two pies right here. And they are divided in this way. So let's go ahead and slice up our pie. Now, in these pies, all we have left are 3 pieces over here on the left side and 1 piece over here on the right side. And it says she will combine the pieces so that they are in the same dish. How much pie will be on one dish? Well, that makes sense. We want to save space. We don't need 2 dishes if they all fit in the same dish. But we have to figure out how much is going to be in one dish. And it seems simple enough. I know you're all like, but Mr. Edwards, I know already what's going to go there. But let's take a look. There's a mathematical step that's happening here. Even if you already know the answer, you did it in your head without even knowing. So we have, let me redraw these real fast. I need to make a little bit more space. So I'm going to put one over here, just like so, and one right here, just like so. Now, we are going to combine these 2 dishes. So once again, let's just get this the way it needs to be. And by combining it, we're actually creating a mathematical equation, believe it or not. So let's go ahead and get another marker color to write our equation down. So we're going to add these together and put them into a single pie dish. Just like so. So let's see. We have, 1, 2, 3 pieces over here and 1 piece over here. So we essentially have 3 pieces of pie plus 1 piece of pie equals 6. Oh, it doesn't equal 6. What am I talking about? 3 plus 1 equals 4. So let's go ahead and shade these in. We have 1, 2, 3, and let's add our 4th piece right here. Seems simple enough. 3 plus 1 equals 4. However, we need to know how much is in each, or how much we need to know how much of this single pie dish is taken up. We know there's 4 pieces, but we need to count how many pieces could fit in here. So let's go ahead and do that. Let's see. We have 1, 2, 3, 4, 5, 6 total pieces that could be in here. Now, we have 4 of those shaded in. So that means that we have 4/6 of a pie. So if we think about it, we actually could have done 3/6, because 1, 2, 3, this is 3/6. We have 3 shaded, 6 total pieces. So 3 pieces are shaded, 6 total pieces possible in this pie dish, plus 1/6 for the same reason. 1 shaded piece, 6 total pieces that this pie is cut into. We only have 1 of the 6, so that's why we have 1/6. 3/6 plus 1/6 equals 4/6. Notice when I added, I did not add the denominators, because if we look at our whole piece, in here we still only have 1, 2, 3, 4, 5, 6 total pieces that can fit into this pie dish. That's what our bottom number is telling us right now, is how many pieces could be in this pie dish. Our top number tells us how many we could have. So if we have 3 pieces in the first one, 1, 2, 3, and we have 1 in the second one, 1, we add those together, we get 4, 1, 2, 3, 4, in the third pie dish. So we took these two, smacked them together, and put them into there. Okay. Now, the next part, that was part A. I should have wrote an A up there. Part B says, suppose Miss Clark eats 2 pieces of the pie. How much pie will be left on the dish? Model the problem using fraction circles. Draw a picture of your model. Then write the difference. Okay. So right now we have this much pie. So let's go ahead and erase this real fast. Let me draw another one. So we've now consolidated it all, and we have put our pieces of pie into a single pie dish. So we have 1, 2, 3, 4. But Mrs. Clark is like, you know what? This is my pie. The bake sale is over, and I'm hungry. I'm going to have 2 pieces of pie. So what does Mrs. Clark do? She eats that pie. But how do we show that? Using math. Well, if I were to eat 2 pieces of pie, I would subtract. So what I'm going to do to represent subtraction is just do this right here. These ones that I'm putting the black marker in, I have now eaten these pieces of pie. So let's see how we could draw that in the same way we kind of did our addition. So as we can see, there's still 4 slices, but 2 have been eaten. So if we draw this, and we first, let's shade in our 4 again. Oops, that's 3, that's 4. Shade in 4. However, we're subtracting now because we're eating pie. So let's go ahead and draw one more. Actually, I'm going to have to draw one more after this. And again, I said the black is us eating the pie. So let's go ahead and we ate those 2 pieces. Those are going away. Well, if I subtract that, that equals this right here. Once I draw my shape, that would equal only 2 pieces of pie left. Now let's go ahead and see if our math lines up. We had 1, 2, 3, 4 pieces. So we had 4 pieces. We ate 2 of them. 1, 2. And we were left with 2 after we ate them. And as we can see, 4 minus 2 does in fact equal 2. However, remember, we're talking about pieces, so these aren't whole numbers we're subtracting. We're actually subtracting fractions of a whole part. So really, I have 4/6. Again, the 6 comes from 1, 2, 3, 4, 5, 6 total pieces, and 4 of those being how much pie I actually have. Then we're subtracting 2/6 because, again, we have 6 total pieces that could fit into that pie dish, but we only ate 2 of them. So we have 4/6 minus 2/6, and what we're left with is these 2 shaded pieces. So we have 2/6 because we have 2 left out of the 1, 2, 3, 4, 5, 6 total pieces that we could possibly have in this pie dish. And just like that, we just did the adding and subtracting of fractions. Once again, I do want to point out, we did not subtract the denominators. We only subtracted the numerators, because the numerators are what we actually have, or we're actually either adding to or taking away. These numbers can change. These numbers do not change. If you have common denominators and you're adding and subtracting, they will stay as a 6 or whatever other number is down there, because it's all talking about the whole piece, all 6 pieces, how much potential there is for that pie dish, while the numerator talks about what is actually in that pie dish. Okay? Now, I'm going to go ahead and move on to page 281 in the Go Math book. So if you didn't hear that, please listen up. Page 281 in the Go Math book. And I'll write it down for you as well. So let's go ahead and write that up here. Again, 4th grade lesson 7.1, page 281. And we're going to do a couple of these as well. So it says use the model to write an equation. Okay, let's go ahead and take a look. I'm going to erase the page number now so I have all my space. So let's go ahead and start with number 1. Number 1 has this amazing picture of these pies. I know mine aren't going to be cut evenly, but I'm going to cut them as even as possible. And that equals one more over here. Okay, so they have that, and then they have 3 shaded pieces, 1 shaded piece, and 1, 2, 3, 4 shaded pieces. Okay, so if we're just counting the shaded pieces, we could say that 1, 2, 3 plus 1 equals 1, 2, 3, 4. 3 plus 1 equals 4 seems like basic math, right? Well, again, we're working with parts of a whole. What that means is we have to count how many pieces are possible to have in this whole. So we have 1, 2, 3, 4, 5. And we have 3 of those 5. Then we have 1, 2, 3, 4, 5. Oops. But we only have 1 of those 5. And we're putting them together, which means we have 1, 2, 3, 4, 5. And 3 plus 1 equals 4, means we have 3/5 plus 1/5 equals 4/5. So this is how you would write an equation to model that problem. Okay, seems basic enough. Let's go ahead and move on to number 2. So let me clean this real fast. And number 2 gives us a shape that looks like this. Again, I'm going to do my very best here to represent it. And then they do something a little wonky. So again, they shade this in like this, and they shade this in like this, and then they say, you know what? Bam, circle with an X in it, because that makes sense. Well, we have to model an equation. So let's start with what we know. We know that we have 3 total triangles this shape is cut into, 3 pieces. So let's go ahead and put that down, because again, we're working with fractions, so we know we're going to have a fraction. And then we have 2 shaded pieces. We're going to ignore the X right now. We have 2 shaded pieces. So 2/3 of our our piece is shaded. Now, this X to me means subtraction. When I see that, I'm like, psh, get rid of it. Okay? So we're going to subtract, and only one of those shaded pieces has an X through it. So we're going to go ahead and put a 1 there. And again, we still have 3 total pieces in here. So we'll do this. So we have 2/3 minus 1/3. If we just subtract across the top, we do 2 minus 1 equals 1. And then we have this down here, which doesn't change, which is 3. We don't do 3 minus 3 because there are still 3 pieces in this shape. Do not subtract the denominators. Do not subtract the denominators. Okay. And with that being said, let's go ahead and do 2 more examples. Oops. Sorry, my camera was doing something weird there for a second. Okay, so let's go ahead and do 2 more examples. And I'm going to leave a little bit of space between these, between my explanation, so you can pause the video and answer the question yourself, or at least give it a try, okay? So, number 3 gives us this shape plus this shape. Oops, let's make that a little longer. Plus, oops, not plus, equals this. Sorry, I'm running out of space over here. I always start off so well over here, and then I have to work around. And then it has this one shaded in, and that one shaded in, and these 2 shaded in. So first, I want you to think how many total pieces we have, how many pieces we have in one hole, and how many pieces do we have in one hole? We have 4. How many pieces are shaded in this hole? 1. Then, again, we're going to bring this plus sign straight down. How many pieces do we have in this hole? 4. How many parts do we have shaded in this hole? 1. So we have 1 part of this hole shaded in, 1 and 4, 1/4, and 1/4 of this hole shaded in. Now, if we were to add these together, we would get, bum-ba-da-dum. We do 1 plus 1 equals 2. Again, we do not add the denominators. You don't add 4 plus 4. 4, 4, this stays as 4. We now have 2/4. See, 2 shaded out of 4 pieces. So our denominator does not change. 4 plus, or 1/4 plus 1/4 equals 2/4. 1/4 plus 1/4 does not equal 2/8. That's a no-no. Okay. Now we're just going to do one more problem, and then that'll be it. You will hopefully know how to add and subtract parts of a whole. So, number 4 gives us kind of a wonky problem. So let me go ahead and draw it out. So we have, and then 1, 2, 3, 4, 5, 6, 7, 8. And then this says 1, this says 1/8, this says 1/8, and all of these little boxes say 1/8. Okay. Now, instead of shading, because the way I did this, I'm just gonna circle the ones that are shaded on the thing, on page 281. I'm gonna circle them with this red marker. So this whole thing is shaded, and then this one's shaded, this one's shaded, this one's shaded, this one's shaded, and this one's shaded. Okay. Now, we also have this right here. So we have this just like that. So I am interpreting this as them telling us that we have, that all of these 8s right here represent one whole piece. Okay, so I'm gonna not necessarily, let's do this actually. Hold on, let's take that off and kind of just show that this is a whole piece. So I'm just gonna do this. So these 8 pieces are the same as one whole. Okay, so we're gonna focus on the fractions down here though. So out of our 1, 2, 3, 4, 5, 6, 7, 8, we have 1, 2, 3, 4, 5 shaded. So we have 5 shaded out of the 8 total pieces. That gives me 5/8. Again, 1, 2, 3, 4, 5. That is where that 5 comes from. And 1, 2, 3, 4, 5, 6, 7, 8. That's where the 8 comes from. Okay? Now, with this X in a circle tells me that we are subtracting these 3/8. So I'm going to go ahead and subtract. And I have 1, 2, 3 that are in that X circle thing right there. And again, I still have 8 total pieces. Now, I'm going to do 5 minus 3, which gives me 2. And if we count, we only have 1, 2 that are shaded and that don't have the X through them. And then we have 8 total pieces still. So that gives us 2/8. So 5/8 minus 3/8 equals 2/8. See, we subtracted the 5 minus the 3, but with the 8 stayed the same. We did not subtract the denominators. And just like that, you know how to add and subtract parts of a whole. And really add and subtract basic fractions. So congratulations. Hopefully you got something from this. And if not, stick around. We're going to do some more videos. And hopefully it helps. But with that being said, have a great day.